Hi everybody, and welcome back to another thrilling episode of the Rusa Master pump reassembly for the Oliver 770 tractor. Let me take a moment to talk about an email I received. Got a message from somebody who repairs pumps, I assume for a living, or at the very least it sounds like they're somebody who has a lot of experience repairing these pumps, and he basically said that he had stumbled upon my video series here and was looking at a few of the videos, and he said he actually had to stop watching me because they made him cringe. So he was nice enough to close the email by saying that he didn't intend to be slamming me with his comments. He said that some of the information I had given was just plain wrong, but he said, to my credit, it looked like that I had gone back later and tried to he said that I had included disclaimers, which I'm assuming he's talking about when I mess up and then I come back in the next video or whenever and I tell you, either by putting a caption on the screen or by showing you that, hey, you know what, I got something wrong, I said something wrong, or I did something wrong, that kind of thing. So anyways, he also was kind enough to say that I could ask him any questions I might have regarding anything I run into. His first question was whether or not I had got the machine running, because he didn't see the whole video series and wasn't aware that I'm still, that it's progress. It's a work in progress. I guess maybe he did see the last video and just thought that maybe I just hadn't uploaded all the videos yet. Pretty much, give you an idea, today is I think February 18th, and we are pretty much up to date right now. The last thing I did was lamented about how I had taken this assembly apart, and after I took it apart I immediately realized I had wished I hadn't done that, because I think I had messed up a setting there. And I ran that by the individual who sent me the email, and he said, yeah, shouldn't have taken it apart, should have left it as it was, should have just done what I had done in the video where I took this, pushed it in and made sure that the little piston in there was moving freely. And he said, pretty much if it's not bound up, then leave it alone. Well, I didn't do that. Took it all apart. So now the question is, how do you set it? Now he was saying that that adjustment, how tight I tighten that plug in, will, put more or less pressure on this spring, which will change the pressure, transfer pump pressure. So he said that that's actually supposed to be done on a test stand. So I'm assuming he means this is supposed to be, hooked up to a machine and run, and the pressure of the pump is checked. And of course I had mentioned that that's a matter of taking this plug out, putting in a special adapter, and then into that adapter you can screw in a gauge, and you measure the pressure, and then you adjust this screw accordingly. What I don't get is why the heck you've got to adjust a screw down inside here when this is where your inlet elbow screws in. So literally you got to hook everything up, run it, test the pressure, and then if the pressure's too low, I guess you just unscrew it, adjust it, screw it back in, and run the test again until you get, what you want for a setting. He did say, though, that he thinks that there's a method I could use that would suffice and get me close enough that I should be okay, or at least close enough so that I could be able to start the machine and run it. And the way he described doing it is to put my piston in and my spring and the plug, and then to push in from the bottom here with my scribe, push this piston in. So he said it's halfway up the slot, with the spring compressed. So the problem is, I don't know if he meant fully compressed or not. So that kind of makes it a little tough. So I'm not quite sure exactly how I'm going to end up doing this. I did find another post on a forum by an individual that I want to mention at this point, because I've come across so many of his, I've read so many of his postings and replies to people dealing with these pumps that I mean, he sounds to me like he's gone and done a ton of these also. And he was the guy who actually, when I first started reading his posts, whether he wants to be blamed for this or not, he's the reason why I decided to attempt this. Because he goes by the screen name J.D. Maris, which I'm not sure if that's J for a first name and Demaris for a last name, or if it's J.D. for John Deere and his last name's Maris, or whatever the case may be. But J.D. Maris is the guy. And any of you who have gone and looked for information on these pumps in the past may have come across some of his posts. But basically, in one post he said that this pump, the way it's made, the construction is very straightforward, and that it can be repaired. And he was cautious to say it's not really a rebuild. What you're doing is, typically what gets done on these is a reseal. Unless you've got damaged parts inside, that these pumps are typically taken apart, cleaned, and resealed, meaning, you know, you buy the kit. And the other big common repair would be the pilot tube, which is that big bushing in the front we talked about, the umbrella seals. And the last thing was, of course, the governor ring, which we had talked about. You know, the original governor rings were made out of some kind of a black material that disintegrates and gives you all kind of problems. The new kit comes with this one. We talked about this already. And of course, the best fix is to forget about this ring, discard it, and buy the solid governor weight assembly, which is what we already have in this pump, courtesy of the last person who worked on it. So, anyways, what was I saying? Oh yeah. So, anyways, so I came across yet another post by JD today that I hadn't seen previously, in which somebody asks him the exact question, which is, how do you adjust the transfer of pump pressure? And the guy mentioned, he says, I think it's through a hex screw down through the where the fuel inlet fuel fitting is. So I knew he had my style pump. He didn't have the style that we were talking about before, where the fuel regulator is mounted on the back of the end plate, or where the fuel regulator is mounted in a separate part of the end plate housing at an angle like this. No, he's got mine. And the interesting thing was that JD had basically told him what to expect for a pressure, and he answered a question. The guy made a direct question as to whether or not turning it in or loosening that screw will increase pressure. And JD said turning the screw in, which would tighten it and put more pressure on the spring, is going to increase pump pressure. So, and then I think JD said should get 60 psi for pressure. And then he went into a whole explanation about why pump pressure was critical. He said that, I'm sorry, I shouldn't say critical, why pump pressure is important. What happens with, of course, if you got, really low pump pressure, you're going to have all kinds of problems. But he said basically, as long as the high pressure section of the pump here is kept wet, fuel is kept, so that's going in there fine and at a high enough rate to, keep up with whatever the RPMs are, that the high pressure part's going to do its job and it's going to fire those injectors. Unless the the pressure's really, really low, but then you get something else going on. So where this pressure regulator is most important is with your advance, your timing advance. Now, that being said, a lot of the pumps I've seen out there of this camera shut off on me. guess I bored it to death. All right, so what I was about to say was a lot of the pumps that I've seen out there, they have a timing advance mechanism. That's a round cylindrical barrel-shaped part that's mounted on the bottom here. That's on the bottom of the body, and it's got usually a a large plug, which my seal kit came with a replacement plug for that. So this plug would be like about here. And you would take it out, and there'd be springs and seals and whatever stuff inside there, and it had to do with a timing advance mechanism. So what that actually did was, as the RPMs would change, that mechanism would actually be able to slightly alter the advance, the timing of the pump. This pump doesn't have that at all. It doesn't exist on this pump. Now, maybe this isn't the original pump, I don't know. Or maybe on the earlier models they didn't have that. Not sure why it's not there. But the point I'm trying to make here, the point I'm trying to come back to is that JD was explaining how that regulated pump pressure is more critical to that mechanism. In other words, you're going to have problems with your timing advance not working properly if you have an incorrectly set pump pressure. So that made me think, well, wait a minute, then logic would dictate, in my world, that since I don't have that advanced feature on this pump, that setting that I messed with right here is less critical than it would be on a pump that did have that. So that's why I think I'm still going to be able to get away with fudging this setting. And I figure the other thing I could do, worst case scenario, is if all else fails and I think it's just a matter of that I don't have the pressure set correctly, I could get this on the machine, and if the machine's running, I could literally put the gauge on it while it's on the machine and use the machine as my test stand, and turn in that screw a little bit if the pump pressure is still a little too low. But that's what I'm going to have to go with, because I took this out. And so now, without further ado, let me get back to some pump reassembly. So I found a picture of a parts breakdown online. I couldn't find the full parts breakdown, but I found a picture of a pump like mine, and it showed the exploded view, and unfortunately it didn't have the part number. But the thing that's important is it showed a call out for this screen. So that satisfied my curiosity as to whether or not this screen was available as a separate part, because I knew that when I went to take this screen off, I might end up damaging it. So to get this screen off, it was on there really tight. I grabbed it with the slip joint pliers, and then I put a hex wrench on here, and I gave it a twist, and I was actually able to get it to move. And the reason why it moved is because what ended up happening was it actually split a little bit right somewhere on here. Right there, I think that's split. Yeah, there we go. I don't know if you could see it. That's split. And that loosened this up so that I could then turn it. But the reason why I was so fired up about getting this off is I'm going to show you. I put a clean piece of paper down, so anything that falls out of here will go onto the paper. And then that way I could see how much gunk had actually gotten in here. So that's the screen. So you can see not a terrible amount of stuff. I mean, it's got to be pretty small stuff anyways, but you can see on there there's what looks like some surface rust and some other crud on there, and there's quite a bit of crud right in here. And then lo and behold, look what seals the bottom of that screen in place, another O-ring. And that looks like that might be the square cut O-ring that I had found in the kit. So let me get my pick out and take that off. Oh yeah, without a doubt, that's the square cut O-ring. or seal. So now I can clean this up better. Well, there were only 2 square cut O-rings left in the kit, and this one's way too big. Here's the original one. This one's way too big. And this one actually is a little smaller, but it's close, and it's the only thing I've got close to that, so that's what I'm going to end up using on here. Alright, I've got this cleaned up now, and unfortunately I do have a rip right here. It's a pretty good sized hole now. As far as the size of this, the holes in this screen go, that's a huge hole, so I am going to have to get a new one of these screens now.